Hello everyone, welcome to Mediverse Atlas, and in this video we'll be discussing briefly the conducting system of heart. So if you have to understand the property of conductivity, we need to know the conducting system of heart. What is conducting system of heart? We know very well that is very basic that conducting system of heart consists of node, AV bundle and Purkinje fibers. Okay, so SA node we have already discussed that the SA node is called as the primary pacemaker of the heart. Why it is called the primary pacemaker? It is because it is the only pacemaker that initiates the stimuli with the highest frequency and conducts the impulse throughout the conducting system of heart. Okay, so SA node initiates the impulses. From the SA node, the impulses reaches the AV node. Okay, from the SA node, the impulse reaches the AV node through this internodal pathways. What are those internodal pathways? We have three internodal pathways. The anterior internodal pathway is called as Beckman. The middle internodal pathway is called as Wenckebach, and the posterior internodal pathway is called as Thorel. So these are the three names that are given to those anterior, middle, and the posterior internodal pathways. Now, through these internodal pathways, they cause the transmission of impulse from the SA node to the AV node. Okay, from the AV node, it reaches the AV bundle. The impulse reaches the AV bundle. Okay, this is the region of AV bundle. From the AV bundle, there is branching of the AV bundle to the right and left bundle branch. Okay, so there is conduction of impulse from the AV node to the AV bundle and from the AV bundle to right and left bundle branch. And further, these branches are divided into Purkinje fibers. So whatever the smaller fibers which we get to see here is are the Purkinje fibers. So this is the entire origin and conduction of cardiac impulse. So this is the pathway. So from the SA node, the impulses are initiated and it is transported to the AV node through internodal pathway, that is Beckman, Wenckebach and Thorel. From the AV node, it reaches the AV bundle, and from the AV bundle, it reaches to the right and left bundle branches, and from that, it ultimately reaches the Purkinje fibers, which supply the throughout the heart because these are minute branches. They supply throughout the heart. Okay. Now, the next one which we are having is the conduction rate. What is conduction rate? So there is these are the values that we need to remember. Okay, SA node, the conduction rate of the SA node is 0.05 meter per second, and for AV node also the conduction rate is about 0.05 meter per second. So the highest conduction rate is for the Purkinje fibers because these are minute fibers with lesser length, so they are responsible for having the highest conduction rate. So the fastest conduction is carried out by which of the following? That is the Purkinje fibers. And the atrial pathway, ventricular muscle, and the bundle of his have the same conduction rate, that is about 1 meter per second. Okay. The another property of heart is the AV nodal delay. What is this AV nodal delay? So delay nothing but there is a delay in transmission of impulse from atria to the ventricles. Okay, this is called as AV nodal delay. So this delay is not pathological, this is physiological. What is the duration of the delay? It is just about zero point 0.1 second. So if the delay is about 0.1 second, that is completely normal and it is physiological. So if the delay is more, if the AV nodal delay is prolonged more than zero point 0.1 second, then that can lead to heart blocks, which is pathological. So that is the difference we need to remember in the AV nodal delay. Now what is the purpose of this AV nodal delay? So this allows the atria to complete its contraction. So it helps the atria to fill the blood completely into itself so that it can pump the blood into the ventricles. Okay, so for the complete contraction of the atria and for the complete filling of the blood into ventricles, this delay is necessary, and it helps in the proper filling of the ventricles. Okay, so it allows the atria to complete its contraction, it helps the proper filling of ventricles and decreases the stimulation of sympathetic nerves, and it increases the stimulation of vagus nerve. Okay, this is all about the AV nodal delay, and this is all about the conducting system of heart. I hope this is clear, and thank you for watching this video.